Alright, we started last Tuesday's lesson with something like this, right? The idea of betweenness. Right? So some problem like B is between A and C, AB is 5x plus 3, BC is 3x minus 2, and AC is 9x plus 7. Right? Find x and AB. How would I start a problem like this? What's that? Yeah, so we will eventually do substitution. First thing you probably want to do is draw a picture, right? What would this picture look like? Yeah, B is between A and C, right? We'll have A, and B, and C, and then we can fill in this information, right? So if AB is 5x plus 3, that'll be this piece. BC is 3x minus 2. And then the whole thing, AC, is 9x plus 7. Okay? So now, how would I set this up algebraically? What would my first step be here? Right, yeah, we're going to say this piece plus this piece equals the whole thing, right? So we started it off using the segments and then substituting in what we know, right? So AB is 5x plus 3, BC is 3x minus 2, and then AC is 9x plus 7. Okay, so let's solve that real quick.
How do you know B directly in the middle, A, C?
We don't.
So they want to be often that 5x plus 3 plus 3. Never mind. I got it. Never mind.
Yeah, no matter where B is, right, it would still be this piece plus this piece equals the whole thing. Right? I guess I made up some bad numbers here because we get a negative answer. Right? But that's still the idea. Since we get a negative number here, it doesn't really make sense to find AB because we would get a negative length. Right? So I made up some bad numbers off the top of my head. Okay, but do we remember that process? Okay, the idea of betweenness. That was the first part of the lesson. The next part, which we only got to do like one sample problem, was the distance formula. Okay, finding distance between a pair of points. So that distance formula was this, right? Distance is the square root of x2 minus x1 squared plus y2 minus y1 squared plus, and I think we only did one example, right? And we kind of rushed through it. Is that right? Maybe. Okay, so let's try a few, bless you, try a few more of these, okay? Finding distance. So on number 7, right, we've got 2 points. We've got A is -1, 2, and B is -4, 6. Okay, so the first thing I want to do is label those coordinate points. Right? I want to label x1, y1, and x2, y2. It does not matter which point I choose to be x1, y1, or x2, y2. So I'll just make the first one x1, y1, the second one x2, y2. Okay, but we do have to make sure that we're choosing one point to be x1, y1, right? It can't be x1, y2. Right? One point is x1, y1, the other point is x2, y2. And then we're just plugging that information in. So we're going to say the length of AB is equal to the square root of, so x2 is negative 4, minus x1 is negative 1. Remember, whenever you're plugging a negative number in, put that in another set of parentheses so that you keep your negative sign straight. Plus y2 is 6, and y1 is 2. Okay. So, just doing some arithmetic now. Negative 4 minus negative 1, that would be the same as negative 4 plus 1. Right? So negative 4 plus 1 gets me negative 3, and 6 minus 2 is 4. So negative 3 squared would be 9. 4 squared, 16. We get the square root of 25. And that's just 5, right? So the length of AB on number 7 is 5. Right. We okay with something like that? Okay, I think on the example that we did, this did not work out to be a perfect square, right? We practiced simplifying a radical. Right? So we're just going to take a few minutes here, right? And you guys are going to practice 8, 9, and 10, right? Finding the distance between those pairs of points, right? If you do get a radical at the end that isn't a perfect square, I want you to simplify that radical, right? I don't want a decimal. I want you to simplify the radical and give me an exact answer, okay? So we'll take a little bit of time to go over the examples where you have to simplify the radicals, okay? Because I know that is difficult to get the hang of, right? If you don't already have the hang of it. So let's take a few minutes here. You guys practice those. All right, we have some answers already. Now these radicals are not simplified. Okay, so these actually have one more step to go. Okay, but did we get this far? Bless you. Okay. So I believe 8 obviously does not simplify. Right? If we get the square root of 2, there are no perfect squares that will divide evenly into 2. But I think both 9 and 10 will simplify. Right? Square root of 356 and the square root of 45. Okay, so do we want to go through any of these entire problems, right? From the start, plugging numbers into the formula. You good on all those? All right, how about simplifying the radicals then? Okay, for this one, if I want to simplify the square root of 356, what does that look like? What's the largest perfect square that will divide evenly into 356? What is it? 18 isn't a perfect square. Alright, so 1, 4, 9, 16, 25, 36, 49, 64, right? Where did I leave off? 81, 100, 121, 144, 169. Right, those are our perfect squares. So those are the numbers that we would want to test to see if any of those divide evenly into 356. 400 is a perfect square, but I don't think 400 goes into 356 either. Did we find one that divides evenly into? 18 is not a perfect square. I think 4 ends up being the biggest one. Right? So remember, all we care about is the perfect squares. Right? I don't care about any other numbers that divide evenly into this, because that's not really going to help me simplify it. All I care about are perfect squares that divide evenly into this. So I can split this up, right, because 4 divides evenly into it. I can split this up into the square root of 4, and I think it's 89. Right? So I can split this up into the square root of 4 times the square root of 89. Now the reason that all we care about is perfect squares, bless you, is that now I can take the square root of 4. Right? I can't take the square root of 18 or 89 or any other number. The square root of 4 is just 2. Right? So this becomes 2 times the square root of 89. Right? And we can't simplify 89 any further, so this would be as simple as I could make this answer. You okay with that? Right, yeah. We just want to find one number that divides evenly into it that is a perfect square. Yeah, for the final answer, yes, because this will split up into the square root of 9 times the square root of 5, right? 9 ends up being the largest perfect square that divides evenly into 45, and then the square root of 9 is 3. Right? So 3 radical 5 would be the final answer for this one. Okay? Feel okay with that? Do we want another practice one or two on that idea, or we feel good? The distance formula? You never have to memorize that, right? That formula, as of last year, for the first time, they give that to you on the formula sheet for the air test. So I'll never make you memorize it since they give it to you on the air test. Okay. Yeah, you just have to know how to use it. Right? And later on in the year, we'll actually learn where it comes from, how to derive it. So you really shouldn't ever have to memorize it, because even if you don't have it, you know where it comes from. We're not going to do that just yet. We'll do that when we talk about triangles later on in the year. Any questions? Feel okay with distance formula and this idea of betweenness? All right, then.